Okay, so let's take a quick look at an early and simple method that illustrates apportionment. Apportionment is the problem of dividing up a fixed number of things among groups of different sizes. In politics, this takes the form of allocating a limited number of representatives amongst voters. Now, in the United States, this is used to decide how many representatives each state gets. So it's not used after an election, it's used after a census to decide how many representatives each state gets. Let's look at a simple example, namely Hamilton's method. So it simply says how close can we get using division. So let's work through some examples. So here is the state of Delaware with 4 counties, and we're going to apportion the 41 members of its House of Representatives. It doesn't actually do this, but it's a nice example. So notice that we have to have the total, and we have to know how many representatives there are. So basically, the first question is we need to determine the divisor. That is, how many people each representative represents. So we're going to do that division. Looks like there's a total of almost 1 million eligible voters as a population, and we're dividing that by the 41 representatives. That gives us 21,900 and change. We leave that in our calculator, or we store it so that we can figure out the quota. In other words, this is saying how many representatives is each county eligible for. And we leave those decimals, at least initially, as we go through and do the division. So you can follow along. Simply take the population of the county and divide it by, no great surprise, the divisor. And there we have our initial quota. Now, notice that this won't add up and it's decimals anyway, so we truncate. That is, we simply get rid of the decimal portion. So for Kent County, 7, for Newcastle County, 24, and for, we've already got this. So the initial is over here, so this is when we simply truncate them. So we already know those decimals. We're leaving those decimals, and then we add them up and see if we get 41, and we're 1 off. So we need 41 representatives. We've only got 40. So now we go back through and we look at our numbers, and we remind ourselves that we kept all of those decimal parts. That gave us our initial allocations, and that only added up to 40. So now we look at the decimal part and we look for the ones that are largest. So 0.0017, 0.58, 0.41. It looks like Newcastle gets 1 more, so that's brought up to 25. The others stay the same, but of course now we have that last seat taken, a representative from Newcastle. Let's look at this again with Rhode Island's House of Representatives. So let's go through and do the whole thing. Notice we've got the total, so we can find the divisor. We simply divide the total number of voters by the 75 seats. That gives us how many voters each representative represents. We then go through and we figure out the quota. So we simply say how many representatives is that many group of voters for each of the counties. We leave the decimal parts. Initially, we need those in the next step, of course. And then we go back in and we give our initial assignments. So that simply means truncating, that is getting rid of, we're not rounding. Notice that 5.9 is not rounded. We're simply truncating. We're getting rid of the decimal portion. And then we add those up and we see how close to 75 we get. It looks like we're 3 off. So we need 3 more seats. So what we do is we look at the decimals and we see that the Newport looks like it's 5.9. The decimal is 0.9, and I don't see anything higher, so Newport gets another seat. But remember, we need 3 more, so let's see, what's the next highest decimal? Looks like 0.83, so we give another seat to Kent. So it goes from 11 to 12. That gives us 2 more, but remember we need 3. So we've dealt with 0.9, 0.8. It looks like 0.5, 0.6, and 0.0. So let's go with the 0.6. So Providence gets another seat from 44 to 45, and then the others stay the same. So Bristol stays with 3, and Washington stays with 9, and now when we add it up, we get 75. This is an exceedingly simple and straightforward and obvious way of allocating seats. That doesn't make it any less powerful. It's just a nice way of fairly ensuring a discrete amounts that those representatives are representing a county in its entirety and not portions of different counties. And then going through and using the decimals to make sure we get the number of seats that we want.